Hi, my name is Haley Wingo, and I am here to discuss Boyle's laws and also the Bernoulli effect. Okay, so what is Boyle's law? The actual definition of Boyle's law is that given a gas is constant temperature, if you increase the volume of that chamber in which the gas is contained, the pressure will decrease. So, what does that mean? It means that every chamber has a normal size and shape. And what happens is when a substance has to enter that, it means that pressure must decrease to allow that substance into it. So, it means it must expand. So, in the reverse of that, though, it means that when a substance is exiting a chamber, it means that pressure must then increase to push that substance out and to return to a normal shape. So, an actual example of that would be using a syringe and water. As you can see, this syringe has a normal shape, but as I push up, pressure is decreasing, and that allows for water to enter this chamber. Because the pressure decreased, the water was allowed to flow in, and it changed its shape. Now, why is Boyle's law important to the human body? Well, just look at your lungs. Your lungs have to be able to increase and decrease size at all times to be able to have oxygen flow in and out. So, when we inhale, oxygen is entering our lungs. Now, our lungs have a normal shape that they always do, but when they expand, that means that the pressure is decreasing as oxygen flows in, allowing our lungs to expand. Now, in the reverse of that, when we exhale, that means oxygen must be pushed out, which means that there must be a pressure increase to push those lungs back into their normal natural shape and to get oxygen out. Now, on to the Bernoulli effect. The actual definition of the Bernoulli effect is that given a constant flow of air or fluid, as at a point of constriction, there is a decrease in pressure and perpendicular to the flow and an increase in the velocity of the flow. Okay, so in layman's terms, what does that mean? It means when there is an airflow, it means that pressure is actually going to be decreasing, and it allows objects to want to go towards where that pressure is decreasing. Now, a very simple example of that is looking at this normal piece of paper. Now, as you can tell, I wasn't pushing air from here, but I was pushing air from here, but yet it lifted. Why is that? It's because where I pushed my airflow, it means that pressure was decreasing, and the object wanted to go towards where the pressure was decreasing, which was up. Now, why is that important to us as human beings? Well, let's take a look at our vocal folds. Our vocal folds must be able to come together and vibrate to produce sound. Well, how do they do that? Very simple. Seeing these two sheets of paper that represent your vocal folds, you're going to push air. And as you can see, as the vocal folds were getting a push of airflow, they ended up coming together. Now, why is this important? Because when that air pushed through those vocal folds, it created a decrease in pressure. And when they came together, they start vibrating, they start rubbing together, as you can hear. That's what your vocal folds do every single time you breathe out. Now, another example of the Bernoulli effect would be something like an airplane. As air comes on top of the airplane, it decreases pressure from below, allowing the airplane to rise up. As just one more example. But putting the Bernoulli effect and Boyle's law together, how does that all fit in? Well, going from Boyle's law, as we inhale, there is a decrease in pressure in our lungs, allowing our lungs to hold it, and then to the reverse, as we exhale, the air is then pushed from our lungs up into the vocal folds, and that is where the Bernoulli effect takes place because of Boyle's law, pushing air out because of an increase in pressure in the lungs, that airflow comes between the vocal folds, pushing them together and vibrating, creating the Bernoulli effect and allowing us to speak. Thank you so much for listening to me. I hope you enjoyed this demonstration about how Boyle's Law and the Bernoulli effect affects human beings and how they work together. Thank you so much.